Hi, welcome back to another Calc 21C vector video this time. And this video is going to be talking about vector length. It's just easy how to calculate the length of a vector. But before that, I'm going to show different shapes that I didn't really show in the last video about stuff in 3D. So the first one is so in a 2D graph, x squared plus y squared equals to 9 is a circle with radius 3. 1, 2, 3. 1, 2, 3. I'm not drawing it as good, but it'll look, wait, did the wrong thing. It'll look something like this. 3, 3, 3, 3. But then on a 3D graph, draw like this. X squared plus y squared equals to 9, since there's no z, and if you remember from the last video, that means z goes from positive infinity to negative infinity, so there's no constraint for z. That means it's gonna still be a circle, but since with radius of 3, 3y, 3x, but since there's no z constraint, it's gonna go all the way from negative infinity to positive infinity, so it's gonna be a cylinder. And lastly, a sphere on a 3D graph. So not really try to draw a sphere, right? But it'll look, wait, let me try to draw that again. Something like this. A sphere like this, the equation would be x squared plus y squared plus z squared equal to whatever the radius, let's say 4 with a radius of 2. That's spheres in 3D with the center at the origin 0.000, and it has the same rules. If you want to move it left 1 on the x, you do x squared minus 1, or however, yeah, something like that. That's just the shapes of vectors. And now for the length, it's a lot easier, and but hold up. The length of a vector, so I'm going to give a random vector, say the vector 3, 3, 2. The length of this vector is just the square root of 3 square plus 3 square plus 2 square. And that's how you do length of vectors. And to do this, you just find 3 squared, which is 9, plus 9 plus 2 squared is 4. 9 plus 9 is 18, plus 4 is 22. And usually in this class, since we're not allowed calculators, you can just leave your answer like that. And that's how you would do lengths of vectors. So it's easy to remember, just the square root of all of them squared, added up. And this is called, so let's name the vectors, and it's called this vector u. This is this, because it's the absolute value of u, which is just, this makes the absolute value since we're squaring it and then finding the square root. And that's the notation to determine the length of a vector. And this is important because later on in the chapter, we can find the angles of these vectors along with the dot products, which is going to be the next video, by using the dot product at the top divided by the length of the multiplication of the length of two of the vectors that you're trying to find the angles in between, and that is the length of a vector.